Math 7, Unit 2, Solving, Lesson 9, Part 2, Solving Addition Inequalities, Situation Problems. A composite figure is made up of a rectangle and an isosceles right triangle, as shown below. The area of the rectangular portion is 16.2 centimeters squared. The area of the composite figure is at least 20 square centimeters. Write and solve an inequality to determine the possible areas of the triangle. State 3 areas for the triangle that satisfy the inequality. First, we're going to have to do some thinking here. The area of the rectangle plus the area of the triangle has to be at least 20 square centimeters. Well, the area of the rectangle we know is 16.2 square centimeters. The area of the triangle is unknown. So we're going to create a variable for that. Let's use x to be the area of the triangle. Okay. So the area of the rectangle plus the area of the triangle, which we're now calling x, has to be at least greater than or equal to 20. Now we can solve this by doing a negative 16.2 on both sides. This will make it so I get x plus 0, which is just x. And 20 plus negative 16.2 is 3.8. So this would be my solution set. All numbers of x where x is greater than 3.8. It does say to state 3 areas that would, for the triangle, that would satisfy the inequality. So let's go ahead and do that. They just need to be bigger than 3.8 or equal to 3.8. So 3 possible areas are, let's go with the boundary point. That is a possible area, 3.8 centimeters squared. We could also have 5 centimeters squared as the area of that triangle and have no problem. We can go as big as we want here, but I don't really want to get carried away. Maybe 7.5 square centimeters. That is also larger than 3.8. Any number greater than 3.8 will work in this situation. If you get into really, really large triangles, they might hang over the rectangle, but I guess we can always make the rectangle skinnier and skinnier. It just needs to have an area of 16.2. Next example. The perimeter of a pentagon pictured below is less than 33 units. Write and solve an inequality to determine the possible values of x. So the perimeter of a pentagon, we would take all the sides and add them together. X plus 5 plus 5.5 plus 4.5 plus 1.5. And all of those together have to be less than 33 units. So less than 33. All right, so as we solve this, so we'll do the same thing we did with equations. We need to simplify both sides. So all of these are like terms. We can add them. 5 plus 5.5 plus 4.5 plus 1.5. That should be 16.5. And that's all going to be less than 33. Now we can solve this by subtracting 16.5 or adding negative 16.5. It means the same in this situation. And we get, I need some more space here, x is less than 16.5. Okay, it doesn't say we need to graph it, we just had to solve it. So x can be anything less than 16.5. Now, question, are there values of x that satisfy the inequality that are not physically possible? If so, explain. I want you to think about this for a moment. 16.5, it's not included, but everything smaller than it is. Well, the number 0 is going to happen here somewhere. And numbers over here in negative land don't make any sense because we are talking about the length of a side of a polygon. We cannot have negative length on the side of a polygon. So negative values are not possible here. Even though they satisfy the inequality, they do not satisfy the situation. So they're kind of extraneous solutions. Anyway, negative because side lengths must be positive. Okay. Next example. In order to break a record time, you must have a time less than the current record. Tying a record does not count as breaking the record. The Utah State High School track and field record for the fastest 100-meter sprint of 10.47 seconds was set by Brian Hazelgren, Murray High, in 1981. So it's actually stood for quite a while, almost 40 years now. Your current best time is 11.03 seconds. Write and solve an inequality to determine what amount of time you must shave off your best time in order to set a new state record. So let's let x equal the time save. You need to save a certain amount of time. Right now you're at 11.03 seconds, and you need to subtract off x, and you need to beat the state record of 10.47, which means your time needs to be less than that. Now we can solve this. It does include a tricky little step that we're going to have to sidestep. We need to get the x by itself, so let's subtract 11.03 from both sides. And this gives us negative 0.56. And we get the opposite of x over here. Now we haven't learned a step that we can use for this, so I am going to sidestep that issue by adding x to both sides. This does give me 0 is less than negative 0.56 plus x, and I'm going to go ahead and add the 0.56 to the other side, and you can see 0.56 is less than x. So, well, actually it'd probably be better if we put the x in front. So you must shave off at least 0.56 seconds. Actually, not at least, more than. You must save more than 0.56 seconds. So you'd have to take off at least 0.57 seconds, which they do records to the nearest hundredth. So if it rounds to 10.47, it's considered the same. So you'd have to get 10.46 in order to beat it. Example 267. Drivers for Jamal's Trucking must travel under a bridge with a sign posted as shown below. The floor of the flatbed trailer is 56 inches off the ground. Write and solve an inequality to determine possible heights of loads that can be carried by Jamal's Trucking. Okay, the first thing, I'm going to draw a picture here. We've got the back of the truck. It tells us the truck is 58 inches off the ground, and we can put a load on that. The bridge is a total of, well, 11 foot 3 inches. 11 feet is, that's 11 times 12, which is 132 inches, plus 3. That's 135 inches. So we need to fit under the 135-inch bridge with whatever load we have on the back of this semi. Let's say that it's shrink wrapped. They usually shrink wrap a pallet. So what is our maximum load height? We'll go ahead and call that x. X equals the load height. Now, according to this picture, it looks like if we take 58 inches plus the load height, we will get the overall height of the truck and load, and that needs to be less than 135. So x plus 58 has to be less than 135. That way it doesn't get doesn't hit the bridge, cause damage. By the way, if you do hit the bridge and cause damage, you would get a ticket. There'd be a fine. You'd probably have to pay for repairs on the bridge if there was damage. So you don't want to run into a bridge with a load that's too tall. So we can solve for x here by doing a negative 58 on both sides. And that gives me x plus 0, which is just x. And 135 minus 58 is 77. So the height of the load on the flatbed needs to be less than 77 inches. If it was exactly 77 inches, you'd probably just touch the bridge, and that might cause damage. You probably want to stay a few inches under that. But you need loads under 77 inches. Okay. I probably wouldn't do anything higher than about 72 inches, giving myself 5 inches of clearance. Okay, on the assignment, number 1, you're going to solve the inequality, graph the solution, and select a solution and check that solution. Let's go ahead and look at E. We would solve this by adding 4 to both sides. This gives us n is less than 9 as our solution. We go ahead and graph that. 9 is going to be the most important number on this number line. So let me make sure I get that on there. It is not included. And n is less, so this includes smaller numbers, less than. Next, I'm going to pick a solution. Let's pick 5. If I do 5 minus 4, I want to see if it's less than 5. 5 minus 4 is 1. 1 less than 5 is true. So that checks out just fine. Number 2, we've got some situation problems dealing with perimeter or shapes in general. The perimeter on A, the perimeter is less than 28 feet. Well, perimeter of a triangle is just adding the 3 sides together. X plus 7 has to be less than 28 feet. Less than 28 feet. Well, x plus 7, we can simplify that to x plus 14 is less than 28. We solve by subtracting 14 from both sides, and we get x is less than 14. Now the problem doesn't require me to graph it, just write an inequality and solve it. So x does have to be less than 14. Number 3 is review of solving. Number 4, find the area of a triangle. Remember, 1/2 base times height. Number 5, you're going to find the median. Remember, the median is the middle number in order. So half the numbers are below, half the numbers are above. Number 6, you're going to evaluate each and show your work of the to create common denominators. Number 7, you're going to look at the graph and write an addition inequality. An addition inequality, just so you know, is something like this. X plus 1 is less than 5. Which, by the way, this would not work for this inequality, because when I solve this, I get x is less than 4. That is not what is graphed. So, well, that was kind of strange. Number 8 talks about a circuit that overloads. There's circuit breakers or fuses that causes circuits to overload so that it does not damage the wiring in your house, which would be a lot more difficult to fix than a blown fuse or a flipped breaker.